Okay, so now we're going to do an independent sample t-test, because most of the time you actually don't know anything about the population mean or standard deviation or anything like that. But instead you're comparing two groups, like in an experiment where you compare one group, like a control group, with a placebo group to see if the experimental manipulation was effective. So we're going to do an example of one of these t-tests where you're comparing two groups against each other to see if the differences between the two groups are big enough to be considered a statistical significant difference. So for example, you could have something like, Dr. Zen is interested in whether or not meditation helps to decrease anxiety. He creates a study in which he has 200 participants. So your N equals 200 total. He randomly assigns them to one of two groups. So you have two groups. Okay? The first group meets once a week for an hour, for a social hour, and this is considered your control group. So our first group is a control group. They meet for an hour, and they have social hour, control group. Okay? Whereas the second group meets once a week for an hour to be led in meditation. So the second group is our experimental group, because they are being led with meditation. At the end of 1 month, he gives a self-report anxiety assessment that rates anxiety on a scale of 0 to 100 to both groups. The results are as follows. So for this example, I'm not going to give you the raw data because you don't want me to list out 100 participants here and 100 participants here to figure out the means and standard deviations and such. So I'm going to give you kind of the summary data. And so I'm going to give you the mean, okay, or the mean, and I'm going to give you sum of squares for this one, okay. So in your first group, your control group, the mean score for anxiety was a 52, okay, and so this, again, this would just be adding up the raw data and dividing by 100, and that's their average score. Whereas the experimental group, their mean anxiety score was a 39, okay. The sum of squares, which you'll recall is a statistic that captures variability. So for the first group was 4,800. For the experimental group, the sum of squares is 4,200. Now there's an example of your book of an independent samples t-test on pages 241 to 242, okay? And they actually figure out things a little bit differently because they use the variance and the standard deviation. I'm going to use sum of squares, but you can use either when you're figuring out your homework. So whatever is easiest for you, okay? So to do a t-test, the equation for t, for independent samples t-test, is the mean of one group minus the mean of the second group over kind of an estimate standard error of the mean of both groups, okay? Now, you'll notice we don't have this kind of equation here, this standard error of the mean for both groups, okay? To figure that out, we actually have to, so we're going to go 3. This is actually going to be our third step. Okay, because we have to figure this expression out. And this expression is going to be the square root of the variance pooled over the sample size of the first group plus the variance pooled and the sample size over the sample size of the second group. And again, you might say, well, I don't know what that variance pooled is. You're right, because we actually have to do variance pooled before we do anything else. So to figure out variance pooled, it's fairly simple. It's the sum of squares of the first group plus the sum of squares of the second group over the degrees of freedom. In the past, degrees of freedom was n minus 1, but here, degrees of freedom when you have an independent samples t-test is going to be sample size of the first group minus 1 plus sample size of the second group minus 1. So it's kind of n minus 1 plus n minus 1. And you'll remember n for the first group was 100, and n for the second group was also 100 because we had 200 participants and we randomly assigned them to one of two groups. Okay, so our degrees of freedom for this particular is going to be 100 minus 1 plus 100 minus 1, oops, minus, this is why I do it in pencil, minus 1, or 99 plus 99, which equals 198. Okay, so we're going to figure out the t for this particular experimental design. So first we're going to figure out variance pooled. So let's do variance pooled over here. And it's the sum of squares of the first group, which is 4,800, minus the sum of squares of the second group, which is 4,200, over degrees of freedom. Oh, sorry, plus over degrees of freedom, which was 198. Okay. If you do your math, and I've done it out for you, it's 45.45 if you round to 2 decimal places. Okay, so we figured out variance pooled, and now we can plug that into the second expression to figure out estimate error of the mean. So we're going to go square root of the variance pooled over n minus 1, which was 100, plus, again, the same expression, over 100, okay? And that's going to equal, if you do it all out, 0.95, okay? So now we have this value that's going to go for our t, so our third step is figuring out our t statistic, and it's the mean of the first group, which was 52, minus the mean of the second group, which is 39, over this expression, which we solved in our last step, which is 0.95. Okay, if you do the math for that, you come up with 13.68. Okay, so that's the t that you get, but again, that's not the answer. You might say, well, what does that mean? We have to figure out what t critical is again. And so I could say, test with a t-test and set the alpha, we're going to set the t critical alpha at 0.05, and we're going to do a one-tailed test, because again, I said that meditation, Dr. Zen believed that meditation would reduce anxiety. So we've got the null would say that these two means, the mean of the first group would equal the mean of the second group, or in the population, the mean of the first group would equal the mean of the second group. Okay? But our alternative hypothesis here would state that our mean of our second group is going to be less than the mean of the first group, because we expect anxiety to be reduced. And this again is our one-tailed test. On our previous example, I told you could actually have two alternative hypotheses. The other one would say that the means do not equal each other, and that would be two-tailed. Okay, but again, I've asked for a one-tailed test, so we're going to go again to page, what page was that again? Let's see, 393 for our statistical table, our t-critical values, okay? And we're going to go alpha 0.05, one-tailed, and we're going to go down, and you might say, well, what's our degrees of freedom? Remember, our degrees of freedom was 198. And you might go down and you go, oh, but it doesn't go to 198. So we're just going to take the last one, infinity. And you'll see that the t critical is 1 point, so the t crit is 1.645. Now, obviously, RT far exceeded that, and so we beat it, okay? If RT is larger than the T critical, we reject the null, and we accept the alternative hypothesis, okay? So in this example, meditation did statistically reduce, or effectively, anxiety. And there you have it. That's an independent samples t-test. So on your homework, you can either use this equation where we use sum of squares, or you can follow your book example where they figure out the variance pooled using the standard deviation of the two groups. Either way, it works the same, it comes out the same, and you just plug in the numbers. And there you have it.